Successful AI platforms. Facebook is a company that leverages AI day in and day out, and without building a scalable platform, that would not be possible. I'm not going to get into technical details today, but rather share with you the lessons that we've learned. And I'm assuming that everybody would agree with me that AI platforms are extremely important. Jan LeCun, which is one of the founding fathers of deep learning, has this story about how the lack of a scalable and usable AI platform in his earlier days in AT&T labs caused a severe slowdown in the rate of innovation that they were working on in the early days of deep learning in AT&T labs. A little bit about myself. I manage the core machine learning group at Facebook. This is a horizontal group that works with the rest of Facebook products. Our goal is to do applied research to develop advanced algorithms and advanced machine learning infrastructure that is used across Facebook. So whenever you log on to Facebook, you're already interacting with the algorithms that we've developed. So if you ever look at the stories in your newsfeed, or if you ever search for something, or if you go to Instagram, all of these run algorithms that were developed by our platform. Our organization is part of Applied Machine Learning, which is an organization that works closely with Facebook AI Research. Facebook AI Research focuses more on academic style research, while our organization focuses on applied research, meaning everything we do will find its way, or most of it will find its way to our Facebook users. All right, so let's get to the top. Building AI platforms is extremely hard. We all know that the discipline of artificial intelligence is evolving really fast. Deep learning, which is among the revolutionary algorithms that we use today, has actually been ridiculed 5 years ago. And I know that that wasn't just true in industry, it was even in academic forums where they consider this just sacrilegious. But now look at how deep learning has revolutionized AI in itself. And these cycles of disruption have actually happened before, so I can only wonder what's next to come. But this poses a big challenge for building any platform. Any platform tries and needs to make assumptions about the future. So how can we make assumptions, or how can we predict the future of what could be the fastest evolving set of technologies that we're seeing in modern history? At Facebook, across the past 3 years, we've applied a specific recipe to building AI platforms. And we've seen it contribute to the success of AI at Facebook significantly. And we believe that this could apply to the rest of the industry. And I would like to share this with you today. So first, let me give you a snapshot of Facebook before we started applying this recipe, around 2012. I actually joined Facebook in that year, which was about 1 year after the Egyptian Revolution. One of my parents is Egyptian, and I saw firsthand how Facebook's mission of connecting the world has huge impact on our users. And so I felt extremely excited about the mission, and I decided to join Facebook, and I initially started working on AI for ads. In 2012, we had an extremely dedicated team. We had a lot of new ideas, and we were extremely motivated. The problem, however, is that the AI platform that we had at the time was slowing us down significantly. It would take us months to ship any new thing to innovation. And then the platform started becoming a snowball of complexity. Every time we ship something new, it just becomes harder to ship something else. So we had to do something, and that's when I decided to spawn off a team dedicated for AI platforms. Now let's fast forward to the present. We call our platform FBLearner, and I'm not going to go into the full technical details here. I'm just going to give you a 10,000 feet overview. The platform consists of two major components. On the left here, or my left, You can see the FBLearner Flow system, which is the learning system. The job of this system is to take in as much data as possible, apply as many algorithms, and learn from that. And then it produces machine learning models, which is then given to the next system, the FBLearner Predictor. And this is essentially a large-scale inference engine. These models are deployed on thousands of machines, and they respond to thousands of requests per second. This in turn generates some feedback loop with our users, which also generates more data that goes back into the learning system. And that also improves the quality of the models that we train, and so on. Now, let's take a look at the learning system, or FBLearner Flow. Choosing the right abstraction for the learning system is extremely important. It took us 2 iterations, and we finally found out that describing any AI process as a computational graph will give you and your organization extreme flexibility and power. So let's take this graph as an example. This is a simple graph. It takes the iris data set on one side and tries to train a simple decision tree. What engineers at Facebook do is they spend their time describing the operations that they want to do on this graph. Each node is called an operator. At times, they could leverage an operator that already exists in the library of operators that we have. And so all their job is just to connect these, to build the connections between these operators. And often at times they have to build their own. But at the end of the day, you start with one operation and then the next until you complete your model. The next thing that is important in the system is to actually make the right level of assumptions. So we want to provide everybody at Facebook with extreme flexibility. Each operator or each node in the graph makes strong assumptions about the inputs or outputs. It assumes that the engineer has explicitly defined those. But what happens in between is extremely flexible. You could implement your own algorithm. You could leverage an algorithm that already exists in the operator library. If a new toolkit, let's say TensorFlow, MXNet, or whatever, comes out, you could just leverage that. And the second important assumption that the system makes is that you're going to explicitly define the data dependencies between these operators. What's interesting is that we often see these dependencies, they change slower. So if you, let's say, want to move from scikit-learn to Torch, both are machine learning toolkits, the dependency coming out of that would not change. In both cases, you're going to produce a machine learning model. So now, what does FBLearner Flow do? The engineer will describe the workflow at the top, and then the graph compiler, which is part of the FBLearner system, will break this graph into smaller components. And it will understand the dependencies, and it will start scheduling them so that as much of them run in parallel. So obviously here, we have to start with this operation, then this one, but then these 2 other operations here on the right could be run in parallel as long as the ones before them are complete. And then we eventually end up with a model. Now, it's very important to mention here that the graph compiler leverages a very large-scale scheduler, which could schedule jobs on thousands of CPU and GPU machines so that we're able to train as many models as we can. There are more details on the Facebook engineering blog, and we are planning to publish a paper about the system in the ICML conference in June. So you can find more details there. All right, so this is a very quick overview of the system. But the proof is in the pudding. And what I'd like to share with you is how did this system change machine learning at Facebook? So every day, the FBLearner Flow system ingests 2 trillion training examples. And every month, the FBLearner Flow system trains 500,000 models. In fact, in 2016, every day we train far more models than Facebook has ever trained in 2012. And the last number is actually the number we're most excited about. 25% of the engineering workforce at Facebook leverages FBLearner Flow in one way or another. What does that mean? This means that we've made AI available to 25% of the engineers without having them to go and start learning more about AI. This is just exactly like a compiler. Our vision is we want to make AI as simple to use as a compiler. Every engineer uses it. A compiler is an extremely important component of the engineering process. But really no one understands or needs to understand how it works. Not no one, only a small set of people needs to do that. But then everybody else in the company can leverage AI to build better products at Facebook. But this is not enough to prove that the recipe works. I haven't yet talked to you about the recipe, which I will in the next few slides. The platform continues to evolve. The platform continues to add tens of new algorithms that we've never planned for. In addition to that, when we actually started designing the platform, at the time deep learning was in its infancy, and it hadn't really picked up at Facebook. But now we have several deep learning applications already part of this platform, like computer vision, machine translation. And we have 20 plus unique applications, all leveraging this platform in ads and feed and search and so forth. So the platform has actually covered a lot of these scenarios. So now, let's talk about the recipe. I touched quickly on this. You really need to nail the architecture of your platform. Without that, the platform may not live as long as you want. Now, there are two lessons that we learned, which are extremely important. The first one, all algorithms are welcome to the platform. You need to be algorithm-agnostic. It is far too common, and I've seen this in many companies, in many places, that whenever a company starts building a platform, that platform, either intentionally or unintentionally, is fully or partially customized for a specific set of algorithms. What that means is you're opening up this platform for disruption, because when these algorithms will go out of favor, and they will probably will, given the rate of developments that we see, you just end up throwing that platform. What we do instead at Facebook is that we've realized that despite of the many algorithms that exist there, they all have commonalities. Every algorithm needs to ingest data as fast as possible, right? Every algorithm needs an advanced scheduling system. The algorithm needs to run on CPU and GPU machines, and so on. So what we decided to do is that we built our platform as a layered platform. We abstracted out the most common components, and we had those as lower layers of the platform. And the higher layers we can customize for particular applications or even particular algorithms. What this means is that if these algorithms go out of favor, as I mentioned, you can fall back onto your lower levels and don't have to reinvent the wheel all again. And that way, you can move super fast as the technology advances. The second ingredient is really important. You need to prepare for disruption. You can hide from it, but you will eventually get disrupted, because no matter what you do, there's going to be far more people working on AI than you have in your own organization. So you have to be prepared for it. How can you be prepared for it? Well, first, disrupt your own self. And here's what I mean about it. Often I see companies building a team to take care of their AI platform, and then they will have either a separate team of data scientists, or this AI platform team will collect and gather requirements, just the normal software engineering process. It does not work, in our opinion, in AI. At Facebook, what we've done is we actually built a team with a diverse set of skills. Here's what I mean about it. The team will obviously have very strong software and infrastructure engineers who understand AI, but they may not necessarily be experts. But also, the team will have data scientists and AI experts who work embedded in that team. And those AI experts, in my team as an example, are focused on particular problems like machine learning personalization or text understanding. Now, the benefit of having these two groups sitting together and working together is that you have this self-cycle of disruption. The data scientists and the machine learning experts will come up with new ideas, and if the platform doesn't really support it, you will quickly know about that, and the platform adapts. Now, there's a third genre of engineering that is also, that is actually often overlooked by AI platforms, and that's UI and front-end engineers. At Facebook, we found out that UI and front-end engineers have actually helped us solve machine learning-related problems in ways we did not imagine before. I am not a front-end engineer, but having those in the team have actually brought in a new perspective. So let me give you a concrete example. The search team in early 2014 wanted to join our platform, but they said, hey, you guys have awesome algorithms, but whenever we have some search ranking results that are not accurate or not good, we want to know the root cause behind that. So it's a question of debuggability. Now, for those familiar with AI, debuggability in machine learning is extremely hard. It's almost sometimes, in some cases, impossible. So they said, look, this is not going to work out for us. So we huddled the team and we started brainstorming, and the front-end engineers came up with an idea and said, hey, how about we start visualizing these models? I mean, I think model visualization right now is a hot thing, but we started that in 2014. And we actually came up with novel ways of visualizing several of these models, which ended up helping the search team figure out why the ranking did not go as well as it was expected. And so my point here is building diverse teams helps you build a better platform and helps you build a platform that could disrupt itself because you have various points of view and various perspectives looking at the problem. All right, so this is my last, this is the last ingredient. You really need to know your users. Now, this sounds like a cliche, but believe it or not, most of the machine learning experts don't really think they have to know their users. Like, they're experts. You gotta listen to what I say. And that doesn't work. When you want 25% or more of your engineering workforce to use your platform, you're gonna really have to know your users. And that actually helps you a lot with figuring out what direction to follow next. Now, at Facebook, we realized we have two major types of users. And this is another mistake that I see a lot of platforms do. They assume one type of user. Majorly, they assume the first one, which is the algorithm designer, someone who writes a new algorithm, or someone who writes a new workflow. These are experts. The platform is designed for them. But at Facebook, we realized that there are far more people who could leverage AI, like a general user. The general user would leverage the algorithm that someone else wrote. Again, if you go back to my compiler example, these are the people using the compilers. And so what we did is we developed our platform with two main entry points. One entry point that is optimized and built explicitly for the algorithm designers, the experts. They tend to often, they prefer often flexibility over usability. And then on the other side, the general user, they prefer usability over power or flexibility. And then something awesome started coming out, which we realized is that on our platform, the work of every expert was being used by 13 other non-experts. And that way, we were able to scale our experts far beyond what we thought we had to do before. The experts don't actually have to work with every and each other application or every and each other team that works on an application. Instead, they could easily build their workflows, include it in the platform, and since the platform has an easy entry point, the other users could just leverage their work with the minimum amount of friction or the minimum amount of overhead. All right, so let's recap the recipe. You got to nail your architecture, you have to plan for disruption, and you have to seed it inside of your team. That helps a lot. And then finally, you really need to know your users. And I believe if you apply those three, I'm hoping that you guys see a similar success that we have seen at Facebook. All right, so that's it.